All right, so this is the RBD review session. Looks like we're going to give Sage a little bit of a break. You won't have to run things. we'll make Josh in the spotlight here. Looks like the focus here was mostly on journaling and mirroring, which Josh, if you can give us a little bit of an overview there. But after that, if there are any questions on RBD work that was in flight for Giant, we can also answer those. So, Josh, if you want to take it away.
Sure. So, RBD mirroring / journaling, we introduced the Giant Summit, and we actually haven't had the chance to work on them yet. But the general idea is that it's an asynchronous replication for RBD, possibly from one data center to another data center, or within one cluster from one pool to a different pool. And the general structure of would be having a journal of all the data that's been written to an RBD image, striped over Rados objects, similar to the way the MDS stripes its journal, and have another process somewhere reading that journal and replaying it on a different cluster or a different pool, or even a different site, perhaps. So there were a number of things we talked about at the Giant Summit for how that could work in terms of the journaling. But what we didn't really define well was how the actual mirroring would be done and how the agent would be structured. So I wanted to talk a little bit about that. So if we have a journal of all the data operations that have been done on RBD image, as well as like metadata things like resizing it or taking snapshots, we can replay from basically from an arbitrary point, and all those operations are idempotent. So we don't have to worry about keeping really too much data about which operations have been replayed so far, as long as we, other than as an optimization to avoid replaying things for too long. But so with the actual agent that does the mirroring, is a question of how it should be structured. Should it work on one image, or should it work on many images at once? Should it somehow coordinate among the other agents that are running to share the work of mirroring a bunch of different RBD images from an entire pool or cluster? I think in my mind the simplest way might be to have sort of one pass over like sort of scheduling process that keeps track of all the RBD images that exist that need to be mirrored, and runs sub processes that actually do the mirroring for each individual sub image. That wouldn't really scale past the network interface for one node, though. But it might be a good starting point. And that would make most sense in a pull model where that kind of agent would run in the destination cluster, where it's mirroring from the source cluster into the destination cluster. If it's running in the destination cluster, if it's just mirroring from to a bunch of images. Since then you can be limited by the network interface in each destination cluster rather than only in one node from the source cluster, perhaps.
Yep. So I'll chime in here briefly. We had a discussion on Ceph a couple months back about this too, where just sort of looking at what the IO model for this is. So it's definitely not free, right? So the cost is basically that for each image that you want to enable mirroring on, you're also writing a journal for it. That's a journaling inside of or on top of Rados. So you get this like another level of writes. But by spending the time to write that journal, then you can use that journal to stream to the other cluster. So if you opt into using this feature, then you'd want to sort of provision appropriately.
Yeah, another thing we mentioned there was that we could have an option to act writes after they've been written to the journal rather than after they've been written to the journal and the normal location, and have and you perhaps use the RBD cache to serve the reads from that for in-progress writes.
Yep, and it might be that if you put the journal in a different pool, like maybe you have the base images on hard disks and the journals on SSDs, which is a sort of a familiar theme, I guess. Then you get sort of low write latency, and the reads would be coming from the disks. Might be okay. Maybe.
Yeah, I think that's definitely something you want to do to just enable that to be in a different pool, since I think it might be a common thing to maybe have the journal not replicated 3 times perhaps while the actual images, or maybe have the journal even erasure coded.
Oh yeah, yep.
Since it could actually be append only.
Right.
You do have to append in bite-sized chunks though.
Yeah, but if they're small enough, then you could have your journal events are always, yeah, I don't know, who knows. That's a possibility. Okay.
Yeah, so I think the general model I've been thinking about this is where one in which you mark an RBD image as wanting to be mirrored, and so it sets some flag on that image, and then there's some question about whether we want to support more than one thing reading from the journal, and how we handle like trimming the journal in that case. If there's only a single like follower to the journal that's replaying it on a different cluster or separate location, it's easy enough to just update a single position marker. But otherwise, we have to know how many there are, and then how many different replication things are reading the journal, and what the position of each of them is. And then something else has to be determined when to trim as well. And maybe that could be the same thing that process that's doing the replication.
Yep. Okay. We can also, yeah. So I think this is the big chunky thing that's sort of on or one of the big chunky things that's on the roadmap for RBD. And the real questions are around where the priorities are going to fall as far as focusing on current issues with, improving performance or robustness or usability or whatever, or sort of biting off a big thing. So I think this is definitely something that would be very valuable for a lot of different use cases. So just to be clear, you can do sort of multi-site replication right now by using the RBD snapshots and snapshot mirroring. So if you periodically take a snapshot of the image, there's a moderately efficient way to get a diff essentially between 2 snapshots and stream just that diff across the network. And one of the other blueprints actually can help improve that somewhat. But this would be more near real time, where you have like a mirror that's seconds delayed or minutes delayed or whatever you configure. But it is sort of a nice enterprisey feature that's not present in any other open source software defined type systems that I know of. So I don't know if there are questions about that. We can talk more about that. I think there's also we can also use this as a catch-all slot for any of the other just random stuff in RBD that we want to address over the balance of the cycle. I think one of the things that we talked about was enabling caching by default.
Yeah.
Or what is the option? It's like cache.
Is right through.
Flush.
Is an option like right through until flush. That's to be safe with older guests that don't necessarily actually send flush operations down. So the cache is just right through until it sees the first flush come through, and then it knows that the kernel supports it.
Yeah. I think we could do that now, actually. So for the next release, that'll be enabled. I think I've yet to hear somebody who doesn't want this actually. So we probably should have done this for Firefly.
Yeah. I mean, for a lot of things, people will have to configure it in the system that's like managing their VMs anyway, since they'll always have the default value there that's kind of overriding whatever default we set as well. But it would help for more general operations like the command line import or export, that kind of thing.
Yeah, and just establish what those defaults should be going forward. So hopefully in OpenStack, then they'll also inherit all these defaults too. Let's see whether
that's one of the ones where it has its own default that overrides it, unfortunately. But yeah.
Yeah. Let's see, what were the other things? There was an object cacher fix that Helm I found when he was doing performance testing, where we fixed sort of the easy one, but there's a different variant. It's like it's doing a lot of iteration, doing write back to identify which objects were dirty or something like that.
Yeah, that's right.
Remember that?
And I think we discussed a little bit about maybe making the object cacher keep better track of which objects had dirty blocks in the first place instead of even iterating through anything.
Mm-hmm. Is there a do you know if we have a ticket open for that?
No, I don't think so.
Okay. Parallelization of RBD export import.
Mm-hmm.
Export isn't particularly fast right now. Let's see what else.
There's some general things that we might want to change for the performance work. Things like adding more trace points for both the object cacher and for the RBD itself to see where things are slowing down.
Mm-hmm.
And with the more recently, there's been a bunch of work in the objector to try to improve latency there and make it work better in parallel. And I think we'll need to maybe upload some of that up into librd and object cacher to take advantage of that parallelism at the RBD level.
Yep.
That might involve
And
things
Adam,
like breaking up blocks, and for example, the object cacher has a one global lock, which you probably need to break up. Go ahead, Sage.
Yeah, yep. I was going to say, well, we're talking about trace points and tracing. Adam Kroom is looking at some of that over the summer too. So I think
okay, cool.
One of the goals is you could have a running, EMU KVM process or any other librd client and attach to the admin socket and start slurping off trace information so you can capture a workload and then replay it later or model it or do whatever. Let's see, an RBD df command is something that has come up where RBD images are thinly provisioned. So if you do Ceph df, you find out how much space is actually used on the pool, but you don't know how much you've sort of promised to users by creating images that are 100 terabytes in size or whatever. So RBD df could have that total separately. You can see how under provisioned you are, I guess, based on that. Really a relatively simple thing. Let's see.
Yeah, it'd be ideal to use the shared flag and bitmaps to do that.
Yes.
Since they provide a nice fast way to get allocated space.
In the last 2 days. How many school
Somebody should mute. Yep. Okay. Let's see. I think the other thing that's sort of stepping up a layer is what the community is lacking right now are documentation, best practices, and tooling to do effective iSCSI gateways. So we have the TGT iSCSI backend. You can also run LIO to re-export RBD as iSCSI. But if you want an HA situation where you do multipath to multiple targets, and that's sort of handled properly in the back end with locking and blacklisting and so forth, so you do the failover in a safe way, there's a bunch of probably like pacemaker stuff that needs to be done to do that correctly. And I don't think there's anything that's at least open that does that right now. But having sort of a robust iSCSI stack is something that people definitely want to see for getting sort of legacy environments migrated over.
Mm-hmm. Yeah, it seems like the main thing there is a lot of testing and documentation. There's also been some discussion about maybe having a user space pass through for LIO to be able to take advantage of newer RBD features.
Mm-hmm. Yeah. Is that just like it's like a fusey thing where you just get like you're just like reading a netlink socket or something, or getting reads and writes?
Yeah, or the interface might be like a memory mapped region that you read and write to, something like that.
Okay.
Where you're receiving commands and sending responses once they're complete.
Yep. Let's see. Deck asks if there's currently a way to monitor which images are using the most I/O, sort of an RBD I/O stat. No.
Yeah, it's another whole area that we haven't really addressed yet.
Yeah. Yeah, I wonder if that's even like an RBD specific thing. It might just be a Rados specific thing where.
Yeah, well, it might be a Rados specific thing where we might want to add like a tag to different operations to associate them with different types of clients, or like for RBD different images, or for the file system maybe different file system users or like that.
Mm-hmm. Yep.
So that you could hook monitoring into that at the Rados level and get better statistics for like different RBD images or different CephFS users.
It might be useful for the RBD or for the OSDs to just have sort of an ephemeral map in memory of that's sort of tallying up the IOs they're doing broken down by client, that the Calamari bits could slurp up and publish somehow. So if you wanted to, you could sort of get a snapshot of, over the last 10 seconds or whatever, or minute, these are the clients that are doing the work in the cluster.
It seems like there'd be a little bit too much to connect the dots between like RBD image and that client name for Calamari though.
Yeah, I was thinking.
We still want some kind of Rados level tag in the message.
Oh, like this is RBD traffic versus this is not.
Or this is RBD traffic for this image even.
Mm-hmm.
It just has some arbitrary identifier associated with it.
Yeah.
I mean, when you're connecting with Rados, you could identify yourself with some kind of an interpreted string, which we could pass through.
Yeah, exactly.
Mm-hmm. Yeah, that'd be useful. Yeah, right now we just have the client identifier and a IP address and port, which might be enough, but better than nothing.
Well, it is enough. It's just hard to connect. So if we had an actual information.
Yeah. What do you think about having the OSD sort of, if they're counting all this up internally, just keeping like, these are the top 10 clients that are doing I/O with me, and then having that be something that Calamari or something else could slurp up and aggregate across the cluster, so you can just see these.
I think that's a great idea.
Like a Ceph I/O top or whatever type of thing.
I also like that you're talking about putting it into Calamari and not Monitor.
Yeah.
Yes. Not the monitor. It shouldn't go to the monitor. Greg will be pleased. Yeah. Let's see.
I think we want to have some kind of like the arbitrary string or some other way to tie it back to individual actual use cases, though. People won't always want to look at this bunch of client IP addresses.
I mean, it could be a JSON object. That way, you could filter based on keys in the JSON object.
Or just a JSON string. The string could be JSON.
Right.
No, well, yeah, right, exactly. But I'm saying that way from the calamari interface, you could look at everything, or all traffic attributable to RBD, or all traffic attributable to RBD image X, or all traffic attributable to client did Y, kind of thing.
Yep. So we could either try to shoehorn this into the existing negotiation stuff that the messenger does with like the authenticator, which would probably be annoying. Or we could just make it so that after it connects, the first message that the object sends is a little ident message that says, by the way, here's a string.
Yeah. Or
I'm not sure you want to make even the first message, but maybe just something later that there's just a separate message that you send that can say, this is my new identity. For example, with RBD, you might not have the identity until later, like after you've connected for a while.
Oh, yeah.
Well, I mean, each OSD op, because you might frequently have an RBD client that's multiplexing a whole bunch of images, right?
Yeah, you could do that too. So if you want to track that, then we would have to send it with each op.
Which would be
instead
fine.
of just that.
Yeah, maybe.
It's a little bit of overhead, but it's probably not terrible.
Yeah.
I mean, if it's bad, we could compress it.
Is my audio working now?
Yep.
Yes.
Cool.
Okay. So I dropped out for a second. Were we talking about having a lookup of an ID that we would attach to Rados requests to some other table of the more complete ID?
Maybe.
So like rather than sending a JSON blob with every request, you'd have like a sort of ID table somewhere and send something smaller with each request.
That sounds like there needs to be an ID table somewhere.
Exactly. Yeah, that does. But the thing is that you need other metadata, right? You're always going to want to be able to resolve like RBD image back to user or file system session back to hostname, that kind of thing, when you want to present it to a user.
Yeah, I think it's easier to just attach all of the information. That way there's no need for a translation table, and yeah.
Yeah, I'm just hesitant to add this like 100-byte blob to every IO.
That's fair.
I mean, in Lustre, you do it with a job ID, and then you look that up via the scheduler. But that's obviously like use case specific, and it's easy because you already have the scheduler server.
Mm-hmm.
Well, so the first time you send an op on a particular session that hasn't been reset, you could send the full JSON blob and a token. And subsequently, as long as the session doesn't reset, you can trust that the OSD remembers the token.
Yeah, that's true.
It's
that sounds right.
That's fine.
Yeah. But within each OSD session object, there'd just be a map.
Or something.
Yeah, that's true.
But then if you have clients multiplexing over the same connections or similar Libreos connections,
so they're gonna. So if a single Libredos client is acting on behalf of 5 images, it's going to send each of those JSON blobs once with tokens 1 through 5, and later it'll just send 3, 5, 4, that kind of thing.
I see what you're saying. Yeah, we could do that. That might be the best, most flexible way to do it.
Yeah. I mean, I wonder if it would make sense to actually bump it up a layer. And so if the client says, I have a workload X that I want to associate with IO with, it would like tell, not the monitor because Greg will beat me about the head and shoulders, but somebody will say, I want to register this workload. I get an ID with, and then I just tag all the O's that way. And that way the OC doesn't even care, it's just passing through.
That's exactly what we're doing here, though, right?
But I'm saying you register it globally, not within an OSD session. So
I don't
register with the cluster.
Do it globally, that doesn't introduce a horrible problem.
Yeah.
I think the best way to do it is to keep it as local as possible. Because the JSON blob itself is a unique identifier, right? So when the OSD is offloading this information to the
Calamari or
Calamari
whatever.
or whatever, it can either compress it or use the same token trick. There's no real need to have a global lookup table.
Other than that, it
Yeah.
could get quite big. I mean, if you
Well,
had,
that's what I'm saying. We can use the same trick. We can maintain a session with the Calamari thing that's stateful enough to maintain a local lookup table, so that we don't have to transfer.
oh right, okay, yeah. No,
But
that's a good
even
idea.
that, I don't think would be worthwhile. I suspect if you just compressed the resulting blob, you wouldn't wind up with all that big an explosion.
Yeah, and we could probably encourage people to keep the blobs, down to sort of tens of bytes for the most part.
Yeah.
Well, particularly since this is Liberados users and they're supposed to be enlightened in the first place anyway.
Yeah. Famous last words. Yeah. Okay. What else? So, I mean, back to RBD. Are there any what other things that are in flight?
Some of the stuff that's in flight is there's some work on the copy on read, which means that for clones, instead of only doing copying data from a parent image when you do a write, you're also when you're reading it, you read the entire object instead of just the section you need, and then write that out to the child image. So it's kind of like an online flattening rather than the standard offline flattening.
Did the user space one land yet?
Not yet. I still need to take a look at that pull request. I think there's still a few little things to fix up with it.
And for the kernel side, there's a blueprint that we'll talk about.
Yeah.
Later today or tomorrow. I can't remember.
Mm-hmm.
Yep. Okay.
So we got about 5 minutes left in the session. If folks have questions, now is the time, I guess, to poke them in there, and they haven't been answered already.
Let's see, the discard on kernel RBD, discard support.
Yeah, that was great.
Also close.
It's very close.
Yet, right?
Yeah.
It's failing two tests. Is that what's going on, or what's?
Yeah, we have much better testing of it now since we illy adapted our FSX to work on kernel RBD as well as libRBD, and so that's been finding a few bugs.
Mm-hmm.
One with apparent overlap handling in the kernel, and then one with discard support, which is what we're still figuring out right now.
And the other thing on the horizon for the kernel RBD side is format 2 striping.
Yep. And all those. Yeah.
Yep. I was just gonna say that libRBD lets you do fancy striping, where instead of just chunking the image across objects, you can stripe across sets of objects with a small stripe size, which is mostly useful for workloads where you have something that is itself like a journal, like say a database that's doing a bunch of small IOs sequentially, and you want to spray those across multiple disks instead of just hammering on one disk for a while and then hammering on the next disk, object disk, whatever. And so it's just adding that support to the kernel side too. Right now it still just does a chunking, not the fancy weird striping modes. That one is a bit of work though, because all of the low level stuff, whatever, yeah, it basically the code needs to be restructured to do more scatter gather and sort of piece IOs together to map a bunch of sort of parallel things to multiple requests and dispatch them in parallel. And it doesn't do that yet. The file system supports this, even though RBD doesn't, but the file system does it inefficiently. So it'll just do like each little piece at a time as separate IOs, and so it'll just go really slow. So hopefully when we do this work, we can have that generic bits infrastructure in there to do that effectively. That'll then capture both the file system and the RBD use cases. But Ilya's, I think, on his way. But again, it's a chunky piece of work. We'll probably focusing on some of the.
I'm here.
Yep. Hey.
Hey.
if you want to talk about that at all.
Well, I don't have anything parallel working yet, so I have, I guess, what you call a one-by-one thing working for the, well, semi-working for the non-parent case. So when there's just a single image without the need to go to the parent, because the parent can have a different striping pattern. So that's all complicated.
Yeah. Yep. But that's coming eventually. Okay.
Okay, does that just about cover off on the RBD stuff then?
Yeah.
I think so.
Awesome. All right, well, let me end the recording here and we'll move on to the RDMA update here. Sure.